Hello and welcome to Genesis Training. This is your trainer Kaustuv. In this video, we'll be handling the topic of time, speed and distance, a very important topic. And in this specific video, we'll be dealing with the subtopic of relation between time, speed and distance. So let's get started with the concept. So first of all, we have three entities over here clearly. Speed, that is equal to distance by time. Then we have time, that is equal to distance by speed, and we have distance, that is equal to speed into time. When it comes to speed, the two major units of speed that we use are kilometer per hour and meter per second. For time, we generally use hour or minutes or seconds. Majorly hour and seconds. Minutes is rarely used. When it comes to distance, we use kilometers, meters, or very rarely miles. Now when it comes to speed, when it comes to these two units, one of the major mistakes that a lot of people make is they forget to match the units. So we have kilometer per hour and meter per second. Kilometer per hour to meter per second, the magic number to multiply is you multiply by 5 by 18. And meter per second to kilometer per hour, when we have to convert, we multiply by the exact reciprocal of this, that is 18 by 5. Now how did this magic number come into existence? It's very simple. If in case you ever forget about this number, you can think about it like this. We have 1 kilometer by 1 hour. 1 kilometer is how many meters? We have 1000 meters. 1 hour is how many seconds? 1 hour is 60 minutes and per minute is 60 seconds. When you reduce this, you will get 5 by 18 meter per second. So 1 kilometer per hour is 5 by 18 meter per second. So x kilometer per hour equals x into 5 by 18 meter per second. That's it. Okay, so a lot of people, what they end up doing is they get confused between 5 by 18 and 18 by 5. When to use 5 by 18 and when to use 18 by 5. I'll give you a nice shortcut to remember that, a mnemonic to remember that. See, kilometer per hour is a big quantity. Meter per second is a small quantity. So whenever you go from kilometer per hour to meter per second, you are making it smaller. So you need to ask yourself, which one is the smaller number over here? Is it 5 by 18 or is it 18 by 5? Clearly 5 by 18 is the smaller number. So we multiply with 5 by 18 when we are making it smaller. And when we are going from meter per second to kilometer per hour, we are going from small to big. We are making it bigger. So that time we multiply by 18 by 5 because that is the bigger number, obviously. 5 by 18, the denominator is bigger, that means the number is smaller. 18 by 5, the numerator is bigger, that means the number is bigger. That's it. This method will help you remember when to use 5 by 18 and when to use 18 by 5. That's it. So this is the relationship between time, speed and distance. Now let's solve a few questions with this knowledge. Question number 1. A person crosses a 600 meter long street in 5 minutes. What is his speed in kilometer per hour? Alright, let's do this. The distance traveled is 600 meters. And the time is equal to 5 minutes. Let's convert it into seconds. How to convert minutes to seconds? We multiply by 60. So we have 5 into 60 seconds. No need to multiply this right now. So let's find the speed. Speed is nothing but distance by time. That is nothing but 600 divided by 5 into 60. 660 gone, we have 10 and that is equal to 2. But this is in meter per second. This is not the final answer because the question is asking what is the speed in kilometer per hour. What did we just learn? How to convert meter per second to kilometer per hour? We are going from small to big. So 5 by 18 or 18 by 5, We are going from small to big. We are making it bigger. So we multiply with a bigger number. that is 18 by 5. That is equal to 36 by 5, that is equal to 7.2 kilometer per hour. That is the final answer, 2 meter per second or 7.2 kilometer per hour. You need to be very careful about matching the units. Let's move along. Question number 2. Walking at 3/4 of his normal speed, Gandalf is 16 minutes late reaching his office. The usual time taken by him to cover the distance between his home and his office is what? Okay, so in such questions you have to ask yourself, what is the quantity that stays constant, which does not change? And that is obviously, you have just three choices, either speed, time or distance. It's obviously the distance over here because it's home to office, office to home, that's all. So we have distance traveled in the first scenario equals distance traveled in the second scenario. With this one equation we can solve this entire question. Distance is nothing but speed into time, so we have speed 1 time 1 equals speed 2 time 2. Okay, now let the default speed be s and let the default time be t equals. Now what is his second speed? It is 3/4 of his normal speed. So 3/4 of his normal speed into how much time? He is late by 16 minutes. That means because he reduced his speed, he is taking 16 minutes more time. So it is the default time plus 16 minutes. Now do we need to change this minutes into hours or seconds? No, because all the options are already in minutes. So we don't need to care about the unit. Let's solve it now. First of all, s and s gets cancelled. This 4 goes this side. So we have 4t equals 3 into 2 is 3t plus 3 into 16 is 48. 3t goes this side. 4t minus 3t is t, that is equal to 48. And that is the answer. The usual time taken is 48 minutes. Answer is A. That's it. Let's move on. Question number 3. Sam and Frodo travel the same distance. Beautiful question. Here itself they have given us the equation. They both travel the same distance. And the different speeds are also given. And they have told that Sam takes 30 minutes longer than Frodo. They have asked us to find the distance. Okay, well and good. So we already have that the distance traveled by Sam equals the distance traveled by Frodo. That means obviously speed of Sam into time of Sam equals speed of Frodo into time of Frodo. Now what is the speed of Frodo? They have given 6 km per hour. And speed of Sam is 6 km per hour. Speed of Frodo is 10 km per hour. This one. And they have told that Sam takes 30 minutes longer than Frodo. Let the time taken by Frodo be t. So the time taken by Sam will be t plus 30 minutes. Now here is the thing. Every speed over here is kilometer per hour and the options are also in kilometers. So we can't have the time in minutes. We need to convert it into hours because we need to match the units. So this 30 minutes will be 30 by 60 hours. Okay. So we have 6t plus 6 into 30 by 60 is nothing but 3 equals 10t. So 10t minus 60 is nothing but 4t equals 3. T equals 3 by 4. But this is not the final answer. They have asked what is the distance traveled by each. The distance traveled. Okay. So we have d, that is the distance. We can apply this. We can substitute this here. Or we can substitute this here and we'll get the same answer because distance traveled by both is same. This is equal to, obviously RHS is much easier to calculate with than the LHS. So D equals 10T, that is nothing but 10 into 3 by 4, that is equal to 7.5 kilometers. Answer is C. That's it. Again, because they were traveling the same distance, that is why it was easier to make the equation. Let's move on. Harry beats Ron by 30 meters or 10 seconds. How much time was taken by Harry to complete the race of 1200 meters? Alright, so we have a race. The length of this race is 1200 meters. Okay, now Harry beats Ron. So Harry is already at the finish line. And when Harry is at the finish line, Ron is 30 meters behind him, or it takes 10 seconds more to cover this distance. How much time was taken by Harry to complete the race of 1200 meters? Okay, so let's find the speed. 30 minutes in 10 seconds. That is nothing but 30 by 10. That is equal to 3 meter per second. Now, whose speed is this? That is the question. This speed is Ron's speed, because Ron takes 10 seconds to cover these 30 meters. Harry is already done with the race. We don't care. So this is Ron's speed. So the time taken by Ron equals, time is nothing but distance by speed. Distance is 1200 divided by speed is 3. That is equal to 400 seconds. But this is the time taken by Ron. They have asked how much was the time taken by Harry to complete the race. Now we all know that Harry finished the race 10 seconds before Ron did. So time taken by Harry is 400 minus 10. That is equal to 390 seconds. That is nothing but 6 minutes and 30 seconds. Answer is D. That's it. Let's move on. Flash and Quicksilver is 90 kilometers away from one another. They are starting to move towards each other simultaneously. So we have Flash over here, Quicksilver over here. They both are 90 kilometers away. Now Flash at a speed of 10 km per hour and Quicksilver at a speed of 5 km per hour. If after every hour they double their speed, so after 1 hour Flash travels with 20 km per hour, Quicksilver travels at 10 km per hour. Another 1 hour Flash travels at 40, Quicksilver travels at 20. What is the distance that Flash will travel until he meets Quicksilver? Okay, now you don't need to calculate too much over here. You can use a little bit of smart guessing to get the answer. Here is the thing. At every hour, if you notice, Flash's speed is double of Quicksilver's speed. 10, 5, 20, 10, 40, 20. Flash's speed is always double of Quicksilver's speed. That means the distance traveled by Flash is always the double of Quicksilver's distance, right? So you can say that 90 kilometers is getting distributed amongst Flash and Quicksilver in the ratio of 2:1. It's always 2:1. So if you divide 90 in 2:1 ratio, you obviously get 60 and 30. So Flash traveled 60 kilometers before meeting Quicksilver. Quicksilver traveled only 30. They have asked about Flash, so the answer is 60. If they had asked about Quicksilver, the answer would have been 30. 2:1 ratio. That's it. So that was it for the first video in this 6-part series of time, speed and distance. We'll look at more questions in the other videos. Thank you so much.